Hello, so welcome to my channel. Today's topic is vector databases. Uh, on day one, uh, we have explained. I have explained RAG. There we use vector databases. Now we will go deep in the topic. We will go deep in the topic. So first of all, what is vector databases? So vector databases are numbers. What is vector first? Vectors are the numbers with meaning. Means like if you have pen, you can convert it to numbers. That pen has meaning in a mathematical space. Okay. So I have closed the book. Okay. So you know now what is vectors. So what is vector database? Vector database is a database where we store the vectors. Okay. So before that we have to do some process to store. So first we have to do embeddings. Like we have paragraphs, or I have PDF of text. If I want to store, I have to do embedding. So to do embedding, first I have to choose a model for doing the embeddings. So like I have selected a model of ChatGPT. So what is embedding model? It is a neural network. It is a network that creates that process the provided paragraph or PDF into embeddings. Okay. So and that embeddings have meanings. Means that embedding converts to vectors, so that have meanings. So it is trained on large data of meaning. Means they already know meaning of text. So the close the like if you, let me take an example. If we have pen and a book, so they are related because to write on a book we need a pen. So they are closely related. So they are close in a vector space. In database of vector there is a mathematical space, large mathematical space, a high dimensional space. There the pen's vector and the book's vector are not close but close. So they are related like that. Means they have meaning. After that, so how can we like find uh, if user puts a query, search a query, gives a query to us, how can we find that in a vector database? So there are like similarity search. Okay, there are uh, three types, or you can say formulas to search it. So first is a cosine similarity, where we use cosine property, where we measure the its like this. There is like this is a vector space, and this is pen and book are close. So what cosine does is it checks the angle, how close it is and how far it is. Okay, how close and its angle. If it is really close, then the cosine value will be 1. If it far away, then it will be like what's the relationship between the book and mouse? So it will be 0 cosine similarity. Same as that we have dot product. It is same but with the length, or you can say magnitude. Cosine with the magnitude means dot product. Then we have something like, then we have, okay, sorry, so I have forgot it. So it is Euclidean distance, where we measure the how it is far. Means on a straight line how it is far, we will measure distance and calculate the relationship. Okay, then we have the next topic or you can say the subtopic, like how we search. We know how we now search, but it has really, if we have 10 millions of vector spaces, if we have 10 millions of vector space, how we can search it? Like one query and search all 10. So we have to apply some algorithms. It Because it is really slow. Why? Because when you search one by all 10 millions of vectors, it is really so slow. So what we do is we use some algorithms. So there is a approximate neighbor navigation, something like that. Navigation, okay. They In that we use HNSW. So what is HNSW? So it is a hierarchical navigible small world. Navigible small world. What it does, it is a provides layers, like top layer, layer 2, layer 3, layer 3, layer 2, layer 1, layer 0. In layer 1 we have the large relationship data, like highways. You suppose highways, city highways. Then in layer 2 we have city roads, like local roads, okay. In that, after layer 1 we have pathways, okay. In after that we have, in layer 0 we have gullies. Means it is a, means big relationship, then small relationship, then all. Means we have big, okay. So this is HNSW. And then we have IVF. It's not inverter fertilization, it is inverted file index, where we uh, it is invert sorry it is in inverted file index. In that we use clustering, okay. We divide into clusters, and we find, first we release query, then in multiple cluster it finds the cluster related to it, then it goes to that cluster and find, find out in that cluster only, then it goes accordingly to the process, okay. After that we have it, we have done. I will see the topic. I forget. Okay, then we have product quantization. It's about memory handling and metadata filtering and hybrid search. So what is product quantization? Like if we are doing too much 10 millions of vectors, it's too much big data. And for this, like it go, if you are doing 10 millions data into the dimensions of embeddings into like 1536 of ChatGPT, so it will be 64 GB something. So it is too much data to store. So we use uh, product containerization, to reduce its size. So what it does is it reduces 6144 bytes into the 96 bytes only, okay. So it is 64 times less memory, but it loses some precision, but it saves the memory. And then we have something like product containerization, hybrid search. Then you have metadata filtering. What it does, like vector, we have vector, so we can provide a data with that vector, like it's like objects, providing object. So we provide vector and then object on, like customer ID and related to that, okay. It is very easy to do. Then hybrid search, where like we can't find a specific keyword in a vector space, so we use BM25. It is a, it loses meaning, but we can use 70% of vector score, means search and the 30% of keyword search means we can, if we merge them both, it will get easy. And the last point is applications, or you can say first, what are the where we can store. It is Pinecone. There is an application called Pinecone. I have used it in my scheme setu AI, where I use drag, and I have stored all schemes, government schemes into that. So and get that, okay. And then